Okay, so what's the current through the 50s? Okay, so this is really just a conceptual question now. So we've got this parallel network here. And the point is that whatever current comes out of the battery, because of the way it's wired, has to go through this 50. So 0.94 amps goes through it. And whatever current is coming out of the battery has to ultimately go back in. There's a law of physics here. It's called conservation of charge, right? So the charge doesn't like amorphously disappear into the circuit. It has to be accountable for at the back end of the battery. So the current here is also 0.94 amps. Okay, was there another question?
Order the light bulbs in terms of brightness.
Ooh, I like it. I know. Order the light bulbs in terms of brightness. It's like, gives us an opportunity to make a little table. Brightness is power, okay? So we've got a 50, we've got a 75, we've got a 45, and then another 50, right? But what we want is the current through and the voltage across, and then we'll calculate the power. Okay. So the current through the 50s was 0.94 amps. The voltage across the 50s was 47 volts. So the power for these is what? 45 watts? What's 47 times 0.94?
44.18.
Let's call it 45 watts. Okay. The current through the 75 ohm resistor light bulb was 0.35 amps. The voltage across it was 26 volts. The current through the 45 ohm was 0.58 amps, and then voltage across it was 26. So what's the power there?
The 75 one is 2.25 watts, and
You sure about that?
yeah,
26 times 0.35?
I got you.
I did.
26 times 0.35.
Yeah.
Oh, I won.
9.1 watts. And then what about this guy?
15.08.
Come on, 15 watts. Okay, so if we were to rank these in terms of brightness, it would go like this. Number one, number two, number three. Okay? So first place, second place, third place. First place, second place, third place. There's really no way to do that. Well, no easy way to do that without doing the numbers. Let me ask you a question. This is going to be a pretty tricky question.
There's one more.
Oh, there's another one? Oh my goodness.
Sorry.
No, go for it.
If they were all wired in parallel, order them in terms of brightness.
If they were, ooh, okay, good question. If they were all wired in parallel, rank them in terms of brightness. So they have the same voltage, and then resistances that go like this. I'm just gonna write one of the 50s because it should hopefully be clear to you that the two 50s will have the same brightness when they're in parallel, because parallel means same voltage. Okay, so I've got a 50, I've got a 75, and a 45. Okay, let's think about this conceptually first, and then we'll think about it mathematically. Power is brightness. Brightness is current times voltage. They all have the same voltage. So the brightest one is going to be the one that draws the most current. This is the brightest. The dimmest one will be the one that draws the least current. 75. And then 50 is in the middle. Okay, so there's also a formula that would tell us power is V squared over R. The bigger resistance is lesser power for the same voltage because it draws less current. Okay, I think that's enough for today. So next time I see you,